Alrighty, so here is kind of the second part of the 5.6 notes. So just kind of put like part 2 is for the 5.6 notes right here. So this is essentially just kind of a quick continuation of what we were doing with the last video with simplifying, adding, and subtracting radicals. And we're basically going to continue that with these few examples here and with these notes. But instead of using square roots, well, except for maybe these last few over here, we're using fourth roots and then cube roots. But ultimately, the same rules still apply when dealing with cube roots and fourth roots and even any other roots. Is when you're simplifying out, your fourth roots and your cube roots, you still want the same exact number underneath the radical symbol or underneath the root sign in order to add the numbers out in front. So let's go ahead and start working out this first example here. So we have negative fourth root of 48 minus the fourth root of 486 minus the fourth root of 3. And we want to, and first of all, we look, is there anything that we can automatically simplify out? That answer is no. So, we can't add any of these numbers together because they're not the same, numbers. So from there, we have to do a little bit of simplifying. So we're doing fourth roots here, and I'm going to quickly write out just the first couple fourth roots that we need to really deal with. So we got 1, which we honestly don't really even need to worry about that. 16, which is 2 to the fourth power, and then 81, which is 3 to the fourth power. And those are really the two that we need to really worry about here. And we want to, when we're breaking these down, we want to split them up as the fourth root. So the fourth root times the fourth root, and we want one of these fourth roots, to be, one of these numbers over here. And it just so happens that if you break down 48, we get 16 times 16 and then 3, all right? And we still got that negative out front. And as we look over here, since 2 to the fourth power is 16, the fourth root of 16 is just 2. And then the fourth root of 3, well, that doesn't really simplify out, so we just leave that as 2 times the fourth root of 3. Multiply by this negative that's still out front, that just becomes the negative 2 times the fourth root of 3. When dealing with the fourth root of 486, and I'm just going to go and kind of confirm with my calculator here real quick. I got a calculator off screen here. That, indeed, so yeah, so if you break down 486, you look for, one of these two numbers right here, and it really is just these two numbers, 16 and 81. You look for one of these two numbers that divides out 486, and if you look, and if you check it out, you get that the fourth root, that 486 divided by 81 is equal to 6. So we can split this up as the fourth root of 81 times the fourth root of 6. And because we look over here, fourth root of 81 is just equal to 3. So we're just going to get right, so it's 3, and then the square root of 6, fourth root of 6, excuse me, that doesn't simplify out. So we just write it as 3 times the fourth root of 6. Still have that minus out and not front, so we're going to bring that down. And then we're going to bring down minus fourth root of 3. This can't simplify out. There's no, fourth root of 3 is going to be a decimal. There's no numbers over here that multiply or that divide out 3, so we're just going to write down fourth root of 3. Alrighty, so now from here, what we're going to do is we're going to start combining our like terms here. And again, we combine, just as we did with the last video, we're going to combine our roots with the same exact numbers underneath. All right, so we have negative 2 times and the fourth root of 3, and then we have this minus fourth root of 3. This is also the same as just minus 1 times the fourth root of 3. And we're just going to combine those together, and really we're just going to add or subtract, depending on what you're thinking there, but literally just negative 2 minus 1 to the negative 2 minus 1, you're going to get negative 3. And then the fourth power, again, that 4 doesn't really change. That is a 4. Sorry for the bad handwriting. So 4 times the square root of 3. The square root of the fourth root of 3 does not change. The 4 outside we don't worry about that. That doesn't change. The 3 underneath doesn't change. We don't add or subtract the 3's. It just stays the same. And we can't do anything more with this negative 3 to the times fourth root of 3. We can't simplify it. It can't combine. So we're just going to write it down here. Minus 3 times the fourth root of 6. Okay. So there's that example. Now we're going to deal with the cube roots over here. So I'm going to quickly draw over here just some cube roots, so just some perfect cubes. I'm not going to deal with one actually. I'm just going to go start with 8, go 27, 64, 125, 216. I'll stop right there. So automatically, starting with the cube roots of 16, 2 times the cube root of 16, and then negative 3 times the cube root of 81. We have a couple different options of how we want to go about this. Right away, we see that the cube root of 16 and then the negative 2 cube root of 16, we can already combine those together to get negative 3 cube root of 16, and then we'll automatically bring down this 3 cube root of 81. Now, okay, so then from there, so we combine what we can combine already. Try to just shorten down the problem so that it's kind of somewhat easier to work with. Now from there, we can't combine the 16 and the 81 together because we can't combine these two together because there's different numbers underneath the radicals. So now we look for numbers now we can look for perfect cubes, which I have a list over here that can simplify out these cube roots. And if I look, again, you just start, taking, our number 16, divide them by our cube roots over here. 16 divided by 8 is indeed 2, so I'm just going to write out the cube root of 8 times the cube root of 2. I'll go ahead and do 81 here. If you check out 81 divided by 27, I believe, and just want to double check one more time, is equal to, 3. So I'm going to divide out cube root of 27 times the cube root of 3. And if we bring this down, we're going to get the cube root of 8 is equal to 2, and then the cube root of 2, we can't do that, so can't do anything with that, so we're going to bring it down, 2 times the cube root of 2. Then we're going to bring down the negative 3 out front, and then we're going to kind of do the same over here, negative 3, and then we have this cube root of 27, which is just the same as 3 times the cube root of 3. And with these numbers out front, again, we're just going to multiply these together. We don't multiply them by the numbers underneath the radicals, just the numbers out front here. We're going to get negative 3 times 2, which is equal to negative 6 times the cube root of 2. And then minus 3 times 3, that's going to give us negative 9 times the cube root of 3. We can't simplify that down any further. And from there, that's probably all we can do with that. That is all we can do with that one. Now, we can simplify down the cube root of 2 or the cube root of 3. We can't combine them any further because they are basically, not the same numbers underneath the radicals, so that's all we can do with that. And then this last example over here, I'm just going to erase these real quick. This is going back to square roots. We should know how to be able to break these down. We got 3 times the square root of 5, 3 times the square root of 2. We can't break any of those down because there's no perfect squares that break them down, or they turn into pretty ugly decimals. 3 times the square root of 20. Look for a perfect square that breaks down 20. If we do that, we will get ourselves the square root of 4 times the square root of 5. And the square root of 4 is obviously 2 times the square root of 5, which again, we can't break that down. We multiply these two numbers out front, 3 and 2. We don't multiply by we do not multiply by the number underneath to get ourselves 6 times the square root of 5. And then we just bring down our other radicals and combine our like terms. We see that we have ourselves square roots of 5s right here. These are the common roots. So I'm just going to go ahead and add the numbers out front. 3 times 6, which just gives us 9 square root of 5. And then we still have this plus 3 square root of 2. We can combine it with the square root of 5. We can't break down the square root of the 2 at all, so we're just going to write it right next to it as 3 times the square root of 2. Right there. Okay, so that's kind of the last example of simplifying radicals out. Now we're going to kind of deal with was essentially the same problem, but instead of dealing, with just straight up radicals, we're actually now going to deal with imaginary numbers. So numbers that are written as, 8i or, i's and whatnot. And with this one, just like, what we would do with our, x, if we were, adding or subtracting variables, we're just going to add or subtract our i's together. All right, we're just going to combine all of our i's together. So we look over here. So first of all, you look for all your like terms. Look for all of your I values there. And look, if you look here, we got negative 8i minus 6i minus I. If we combine all of those together, we're going to get ourselves negative 15i. Because again, all we're doing is just adding the numbers out front. Negative 8 plus a negative 6 is negative 14 plus a negative 1. That gives me negative 15. And then from there, we add all of our numbers out in front. 10 plus 4 is equal to 14 minus 7 gives me just a 7. We combine all those together, I get negative 15i plus 7. Okay? Now over here, now we are introduced to some I squared. So now remember what we did yesterday. Remember that I squared is the same thing as negative 1. Okay? So anytime that we can substitute in a real number for our imaginary numbers, we want to go ahead and do that. You know, if we can see that, hey, we can substitute in negative 1 for our I squareds here, we can go ahead and do that. So there's a couple different things. You can, if you want to, you can automatically, you know, put in the negative 1s for the I squareds, you know, multiply all the I squared values by negative 1. Like and turn this into a negative 9, turn this into a positive 5, turn this into a negative 4. Or you can just go ahead and, you know, simplify what you have already and then go from there. I'm going to go ahead and simplify out from what we have already. So combine your like terms just like as we would do with, you know, x's or x squareds. We're just going to combine all the I values with the same exponents. So I'm going to combine out my I squareds. My 9i squared minus 5i squared gets me 4i squared minus plus 4i squared to get me 8i squared. Combine my i's here. I get 8i minus I, that just gives me a 7i. And then my negative 12, that just turns into negative 12. So I'm going to rewrite it over here. 8i squared plus 7i minus 12. But remember, I know that my I squared here is equal to negative 1, so I'm going to substitute in negative 1 for that I squared there. So this is going to turn into 8 times a negative 1 plus 7i minus 12. And then, you know, obviously 8 times a negative 1 turns into a negative 8 plus a 7i minus 12. And then from there, you know, this turns into just, you know, combining the rest of your numbers out. Negative 8 minus 12 gets me negative 20, so I'm just going to write this as 7i minus 20 right there. Right, so that is the end of adding and subtracting out radicals. Again, thank you guys for watching. I will have the next videos up soon.